Overflow flag. Before discussing the overflow flag, let us revisit two's complement number representation and what is the overflow. We are considering 4-bit numbers. With 4 bits, I can create 16 distinct patterns 00002 F, that is 1111. This is an hexadecimal and this is decimal. We are discussing two's complement number representation. In this pattern, you can see there are certain patterns with m must be is equal to 0 and certain patterns with m must be equal to 1. We know in sign magnitude form, the positive numbers are represented using sign bit equal to 0, that is m must be equal to 0, and negative numbers are represented using m must be equal to 1. And the remaining bits are used to represent the magnitude. In two's complement representation, positive numbers are represented as in sign magnitude form and negative numbers are represented using the two's complement of the representation of positive numbers. So the positive number, so I'm using this patterns with must be equal to 0 to represent positive numbers. So it will be 7, 6, 5, 4, 3, 2, 1, 0. The patterns will be 0, 1, 1, 1. 0 must be used for sign bit and the remaining bits are used to represent the magnitude. 0, 1, 1, 0, 0, 1, 0, 1, 0, 1, 0, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, and the negative numbers. What is minus 1? Representation of minus 1. This the two's complement of the representation of positive 1. That is positive 1 is 0, 0, 0, 1. Its one's complement is 1, 1, 1, 0. Its two's complement is 1, 1, 1, 1. So the representation of minus 1 is 1, 1, 1, 1. What is minus 2? The representation of positive 2 is 0, 0, 1, 0. Its one's complement is 1, 1, 0, 1. Its twos will be 1, 1, 1, 0. 1, 1, 1, 0. I see minus 1 is 1, 1, 1, 1. Minus 2 is 1, 1, 1, 0. And minus 3 will be 1, 1, 0, 1. 1, 1, 0, 1. minus, this is minus 3, and minus 4 will be 1100, and minus 5 will be 1011, 1011, and minus 6, that will be 1010, then minus 7 will be 1001, 1001, and one more pattern remains 1000, it is minus 8, 1000. In hexadecimal, this is in hex, this is 8, and this is 9, this is A, this is B, this is C, D, E, F, this is 0, 1, 2, 3, 4, 5, 6, 7. That is, the pattern for minus 6 is in hexadecimal. You read the pattern, it is A. So using 4 bits, you can represent minus 8 to plus 7 using 4 bits. That is the range of 2's complement numbers you can represent using 4 bits. Next, let us check what is the overflow. Let us revise subtraction using 2's complement. We will take two numbers, 25 and 13. We want to perform 25 minus 13. What is the pattern for 25? Pattern for 25 is 16 plus 8, 24, plus 1 is 25. So the pattern is 11001, and for 13 is 0, 1, 1, 1, 0, 1. And 25 minus 13 is 25 plus minus 30. So what is minus 13? It is nothing but the 2's complement of the pattern for 13. So it is 0, it is the pattern for 13 is 0, 1, 1, 0, 1. Those ones is 1 0 0 1 0. Post pulses 1 0 0 1 1. 1 0 0 1 1. This is the twos of 30. So we have to perform 1 1 0 0 1, that is 25, plus twos of 13, that is 1 0 0 1 1. Result will be 1 plus 1, that is 0, 1 carry, 1 plus 1 0, 1 carry, 1 plus 0 plus 0 1, 1 plus 0 1, and 1 plus 1 0, and there is a carry 1. This one is carry. So in close complement subtraction, if a carry occurs, we will discard the carry. The remaining pattern will represent the result. So here the pattern is 0 1 1 0 0. It is 12. Binary of 12. So result is 12. Remember, in two's complement subtraction, if a carry occurs, we will never consider that carry. Next, let us perform 13 minus 25. 13 minus 25. So what? So it is 13 plus minus 25. 13 plus minus 25. What is the pattern for minus 25? So we have to take the twos of 1 1 0 0 1. Pattern for 25. Its ones is 0 0 1 1 0, and those will be 0 0 1 1 1. So this is 25. Once is this, twos is this. Then we have to add the pattern for 13 and twos of 25. So pattern for 13, pattern for 13 and twos of 25. 13 was 0 1 1 0 1. Twos of 25 is 0 0 1 1 1, and the sum will be 1 plus 1, it is 0, 1 carry, 1 plus 1 0, 1 carry, 1 plus 1 plus 1 1, 1 plus 1 plus 1 1 1, 1 carry, 1 plus 1 1 0, 1 carry, 1 plus 0 plus 0, it is 1. So it is 1 0 1 0 0. If no carry, the result is negative, and this is the result, and it is representing minus 12. So we got the result minus 12. Let us check whether it is correct or not. What is the pattern for 12? It is 12 is 0 1 1 0 0. What is that? Twos of 0 1 1 0 0? Its ones is ones will be 1 0 0 1 1, and twos will be, you have to add 1, so the twos will be 1 plus 1 0, 1 plus 1 1 0, 1 carry, again 0 1 carry, so 1 plus 0 1 0 1. So this is twos of 12. Here we go 1 0 1 0 0 as the answer. It is nothing but twos of 12. So the result is minus 12. Our calculation is correct. Next, let us come to the two's complement representation of numbers using 4 bits. See here you can see the range is from minus 8 to plus 7. Well, let us perform 2 plus 3. Our target is to understand the concept of overflow. 2 plus 3 we are performing. We know the pattern for 2 is the pattern for 2 is it is positive 2, so it is 0 0 0 1 0, and 3 is 0 0 1 1. Their sum will be 1 1 0 1 carry. So 1 plus 0 plus 0 1, that is 0. This is 2 plus 3, but the result is 0 1 0 1. You can see the pattern 0 1 0 1 here. Answer is 5. So the result is within the range -8 to +7. So there is no overflow. No overflow. Next, let us consider 2 plus 6. 2 plus 6. The pattern for 2 is 0 0 1 0, and for 6 is 0 1 1 0. The sum is 0 1 plus 1 0 1 1 carry, 1 plus 1 0 1 carry, 1 plus 0 plus 0 1. The pattern is 1 0 0 0. In our representation, what is the pattern 1 0 0 0? It is -8 actually. The pattern, we got the result 1 0 0 0, but our pattern represents -8 in 2's complement representation. So the result is wrong actually, isn't it? For a signed numbers, we got the pattern 1 0 0 0. This pattern represents -8. So we got -8 as the answer. We got -8 as the answer. Because from the table we are getting the information that this pattern corresponds to -8. So the answer is not correct, and we will say there is an overflow. That is, E3 is our MSB, and the MSB is our sign. Here you can see a carry flows from D2 to D3. We position D2 to D3. Now we will say there is an overflow. See, in the context of unsigned numbers, this is correct. 2 plus 6, 6 is 8. The pattern is 1 0 0 0. But in the case of unsigned numbers, the answer is not correct. That is the matter. And it is represented by some flag. That is our overflow flag. Let us consider another example. -8 minus 2, or -8 plus -2. We know the result. What is the pattern for -8? It is 1 0 0 0. 1 0 0 0. -2, it is E, isn't it? -8 plus -8 minus 2 is actually, we can say it is E plus E. If we follow the hexadecimal. So the pattern for -2 is E, it is 1 1 1 0. 1 1 1 0. The sum is 0 plus 0 0, 0 plus 1 1, 0 plus 1 1, 1 plus 1 1 0. We can see there is a carry. That is, see, this is our D3, this is our D2, this is our D1, and this is D0. Is there any carry from D2 to D3? Previously we said when a carry happens from D2 to D3, a overflow occurs. The answer is not correct. Okay. See, is the answer correct here? -8 plus -2. Is the answer correct? It is out of range, isn't it? -8 plus -2 is -10. It is out of the range. So there is an overflow. But there is nothing from D2 to D3. D2 to, previously we said once a carry moves from D2 to D3, it should indicate by overflow flag. There is overflow occurred. But here D2 to D3, nothing. Here we have a carry from D3 to carry. So D3 to carry flag. This happened. In this case also, the result is not correct. It should be indicated by the overflow flag. See, the result is not correct in the case of sign numbers. So it should be indicated using an overflow flag because an overflow occurred. The answer is not correct. So we can't say the overflow occurred on the basis of a carry flow from D2 to D3. Okay, see here D2 to D3 carry never occurred, but an overflow occurred. So we can't tell it based only on a carry flow from D2 to D3. That is from the previous position to A must be in general. Let us take another example. minus 1 plus minus 6. What is the pattern for minus 1? It is F, that is 1 1 1 1, and minus 6 is minus 6, it is A, 1 0 1 0. What is the sum? Is 1 1 plus 1 1 0 0 1 carry, 1 plus 1 1 0 1 carry, here 1 as a carry, 1 1 1 0 0 1 1 1 0 0 1. Here D3 to the must be for carry flag, for carry occurred. Then what about D2 to D3? D2 to D3. This is D2. Nothing occurred. Is the answer correct? Minus, sorry, 1 plus 1, 1 plus 1 0, 1 plus 1 0. Okay, D2 to D3 is here. So both D2 to D3 and D3 to carry flag occurred in this case. Since D3 to D3 occurred, we have learned that there should be an overflow. Considering this, is this answer correct? Minus, what is minus 1 plus minus 6? It is minus 7. We got the pattern. See, in 2's complement subtraction, once a carry occurred, we will discard that. We got the pattern 1 0 0 1. The remaining represent the pattern. Remaining bits represent the pattern 1 0 0 1. What is 1 0 0 1? It is minus 7. It is correct. Minus 1 plus minus 6, it is minus 7. Answer is correct. But here there is no overflow. So in what condition this overflow occurs, or overflow flag will set? Overflow flag is used to indicate some wrong answer in the case of signed numbers. So in what case overflow flag will set OF flag equal to 1? In what case this will be set? Previously we said once a carry from D2 to D3 occurs, overflow flag will set. Then we said overflow will happen if a flow of carry from D3 to carry happens. But it is wrong in this case. Here no overflow. Our answer is correct. Then how do you say when this OF equal to 1, that is overflow flag will set? It depends on a flow of carry from D2 to D3 and D3 to carry, isn't it? The setting and resetting of overflow flag depends on a flow of carry from D2 to D3 as well as D3 to carry. Okay, then we will say your overflow flag, which is equal to the condition D2 to D3 occurred, a carry flow from D3 to D2 to D3 occurred, XOR a carry flow from D3 to carry occurred. We can say it like this. Overflow flag, it is the XOR of D2 to D3 carry flow and D3 to carry flow. Let us take some 8-bit number and check whether it is correct or not. This table shows the 2's complement representation using 4 bits. Suppose a 4-bit register contains the value 1010. What is meaning? In unsigned arithmetic, the register contains the value A in hexadecimal or 10 in decimal. But in signed arithmetic, its meaning is the register contains the value -6. So this is the difference. If a 4-bit register contains the pattern 1010, in unsigned arithmetic, its meaning is the register contains A in hexadecimal. In signed arithmetic, it contains the value -6 in decimal. Next, let us see 8-bit numbers represented in 2's complement form. First, we have to decide what is the maximum positive number and minimum negative number we can represent using 8 bits. See here 4 bits, the maximum number is positive number is 7, that is 2 to the power 3, that is 4 minus 1. In general, n minus 1, that is 2 raised to 4 minus 3, that is 8 minus 1. And negative number in general it is minus 2 raised to n is the number of bits, n by 2 to the power n minus 1. Here we have, if we are using 8 bits, 2's complement numbers using 8 bits. The maximum positive number we can represent as 2 raised to 7 minus 1, that is plus 127, and the negative number, the minimum negative number, we can represent using 8 bits is 2 raised to n minus 1, n is 8, is minus 128. The maximum positive number is 127, and the minimum negative number we can represent using 8 bits is minus 128. So our range is minus 128 to plus 127. Suppose a register, let us take some CL. CL equal to some 90 in hexadecimal. It is not 90, it is 90 in hexadecimal. What is its meaning? If it is unsigned arithmetic, it will be 90 in hexadecimal. It will be 144. The number will be 144. It is in unsigned arithmetic. If it is in signed arithmetic, what will be this number? This is in unsigned arithmetic. Then what is in, if it is signed arithmetic, what is this 90? Okay, let us check. 90 is nothing but the binary pattern 1001 0000 0000. That is, see the MSB, it is 1. That means it is some negative number in signed arithmetic. And this represents minus x. See, negative numbers are represented using 2's complement of the representation of positive number. So this is the 2's complement of plus x. We want to know what is x now. Okay, so let us decrease 1. You will be getting 1 0 0 0 1 1 1 1. Its ones will be 0 1 1 1 0 1 1 1 0 0 0 0. 8 bits. It will be 7 0, isn't it? This is 7 in hexadecimal. So what is 7 0 in hexadecimal? 7 0. This is in hexadecimal. So let us convert into decimal. It is 112. That is 90 in hexadecimal. That is our CL register contains the value 90 in hexadecimal. Its meaning is in unsigned arithmetic. Sorry, signed arithmetic. In signed arithmetic, it represents minus 112. Minus 112. That is CL content equal to 90. In unsigned arithmetic, it represents the decimal value 144, 144, and in signed arithmetic, it represents the value minus 112. Or in hexadecimal, it represents the value minus 70. Next, let us consider some arithmetic operation with this 8-bit numbers. Let us consider the number 35H plus 5BH. 5BH. The numbers are in hexa 35 and 5B. What is the result? If we add them 35 plus 5B, will the overflow flag set? That is the question. What will be our overflow flag? So what is this 35 actually? in decimal. Let us think in decimal. Okay, so equal to set to decimal. Set to decimal. That is 53. And what is 5b? It is 91. What will be the result? It is 144. That is the sum in decimal. Then what about in hexa? What is 5 plus b? 5. B is 11, so 16 it is 1 0. So it will be 0. Then 1 carry. 1 plus 3 plus 5. It will be 9. It is 9 0 in hexa. Will the overflow flag set? So the first question is it within our range? That is the range of numbers that can be represented using 8 bits. C, the smallest number is minus 128 and highest number is plus 27. And this number is 144. It is not in the range. Definitely it should be indicated by setting the overflow flag. Okay, let us check the bit patterns. For 35 is 0 1 0 0 1 1 and 5 0 1 0 1. Then 5b it is 0 1 0 1. B is 1 0 1 0 1 1. Okay, let us use one cell for one bit. 3 is 0 0 1 1 and 5 it is 0 1 0 1. Sorry, 0 1 0 1 and 5b it is 0 1 0 1 and b is 1 0 1 1. If we sum up, this will be 1 0. So 1 carry, 1 plus 1 0, again 1 carry, 1 plus 1 0, again 1 carry, 1 plus 1 0, 1 carry, 1 plus 1 plus 1 1 1 1 carry, 1 plus 1 0, 1 carry, 1 plus 1 0 1 carry, and here it ends 1 plus 0 plus 0. So what you are getting, it is 9 and this is 0. So the result is 9 0. In for which we said that our flow flag will be setting if D3 to D2 to D3, a flow of carry. Here the MSB is D7. Okay, so D7 D6. So here D7 to D7 to D6, a carry flow occurred, and there is nothing from D7 to MSB to carry flag. There is nothing going out of D7. This happens and this is happening. Okay. So see, we know in signed arithmetic this is not correct. So definitely because the result is out of the range. So overflow flag should be on. Okay, in previous case we have represented OF equal to XOR of two conditions. Here also we can write the same thing. OF equal to D7, sorry, D6 to D7. Okay, sorry, D6 to D7 XOR D7 to carry. So here overflow flag is set. Next, let us see another example. 35 hexadecimal and D3. Let us check what is 35 and D3 in decimal. D5 we already calculated, it is 53 and D3 is 211. It is correct. Okay, let us take extrude. Okay, it is 211. Okay, and D3 is 211 in unsigned arithmetic, isn't it? A register, an 8-bit register, some CL, which is equal to D3H. Okay, what is the meaning? In unsigned arithmetic, this is okay, but in signed arithmetic, this represents some negative number. See the MSB. What is the pattern for D? Something 1 1 0 1, isn't it? The MSB is 1. So this represents some negative number. Okay. Then what is that negative number? B is 1101, A10, B11, C12, D13, 1101, 0011. Okay, this was the pattern. You subtract 1 minus 1, you will be getting 0010. Here you are getting 1101. Then if you take 1's complement, it will become 0010, and this is 1101. That is hexadecimal 2 and 13. Hexadecimal 2D. Sorry, 2D. What is 2D in decimal? 2 into 16, 32 plus 13, 45. So this number actually represents minus 45 in signed arithmetic. Okay, this number represents D3. CL equal to D3 hexadecimal means in signed arithmetic CL contains the number minus 45. Okay, let us do this. 30 sorry 35 plus D3. So actually this represents the number minus 45 in signed arithmetic. What is 350011? Sorry, I will use one with one cell. 0011. 5 is 0 1 0 1, and D is 1 1 0 1, and 3 is 0 0 1 1. Okay, if we add 1 plus 1 0, carry 1, 1 plus 1 0, carry 1, 1 plus 1 0, carry 1, 1 plus 0 plus 0, it is 1. Here 1 plus 1 0, carry 1, 1 plus 1 0, carry 1, 1 plus 1 0, carry 1, 1 plus 1 0, carry 1. Okay, here a carry moves from D6 to D7, and a carry moves out of D7. Okay, that is here D6 to D7 carry moves, and D7 to carry flag. Then is the result within the range? What is this? It is 0. Then this pattern is 8, that is 0, 8. Is it in our range? The hexadecimal number 0, 8. Is it in our range? Will the overflow flag set? That is the question. Here overflow flag equal to 0. Overflow flag will not set because result is in our range 0, 8. This x number, it is in our range, so there is no overflow. Remember, in toes complement subtraction, if a carry occurs, we discard the carry and the remaining pattern represent result, and it will be a positive number. So here there is no overflow, so OF equal to 0. See, both this happened. This is yes, and this also is. If you take the XOR, it will be 0. So OF will be 0. This overflow flag works. See, we have performed the addition 35H plus D3H. In signed arithmetic, 35H represents 53 in decimal and D3H represents minus 45 in decimal. Okay, D3H represents 211 in unsigned arithmetic. Here we are dealing with signed arithmetic and our overflow flag is related to that. So in signed arithmetic, D3H represents minus 45. See, 53 plus minus 45, it is 8. Okay, so there is no overflow. It is within our range, minus 128 to plus 127. So there is no overflow. So this flag will not set. Let us try a small program with the data we use to explain the working of overflow flag. See, the first instruction move BL comma 35H and then add BL commas D3H. This where the data we used in our example. You can see the result 35H. The pattern is 0011 0101. See, there must be, it is a positive number. It represents 53. D3 is a must be 1. It's a negative number actually inside arithmetic. It represents minus 45. And you sum up, I will get the pattern 0001000. The carry will be there, and the result is within our range. The 8-bit range is minus 128 to plus 127. So overflow flag will never set. Okay, let us run this program. Let us load it with turbo debugger. Remove BL comma 35H, then add BL comma D3. See, BL is loaded 35. See, now the overflow flag is 0. We are performing add BL comma D3. See, overflow flag remains in a reset state. Now let us see the question. Move BL, 0 FEH, then sub BL, 7F. So BL will be BL equal to FE, hexadecimal value. Then it will be performing BL equal to BL minus 7F. Okay, will it set overflow flag? Or what is the status of overflow flag after executing sub BL, 7F? That's the question. Okay, let us check what is this FE. So the value hexadecimal and decimal, and what is it in signed arithmetic? Hexadecimal value is FE. Decimal value will be 254. And what is it in signed arithmetic? FEH, that is 1111, and A is 1110. If is this is the truth of some value, then if we subtract 1, we'll be getting 1, then 0, then 1 1. We're getting 1 1 1 1. So this will be the pattern 1 1 1 1 1 1 0 1. Then it's ones is 0 0 0 0. So this is getting by doing minus 1, and now you are taking ones. So this the pattern will be 0 0 0 0 0 0 0 0 1 0. So it is actually 2. So in signed arithmetic it is minus 2. If we means in unsigned arithmetic it is 254, and in signed arithmetic it represents minus 2. Then what is this 7F? It is 127, and this represents this see the pattern 7F, 7F. The pattern is 0 1 1 1 1 1 1 1. See the must be it is 0, so this is a positive number. So this will become BL content is FE. FE means minus 2. So it will become minus 2 minus 127. Okay. So definitely it is minus 129. Result will be minus 129. So this is not in our range. Our range is from minus 128 to plus 127, and the result of this operation is minus 129. It is out of our range, so overflow flag will be 1.